Okay, so we use these things literally every single day, right? But have you ever really stopped to think about what's actually happening inside? Behind the screen, there's this fundamental blueprint, a kind of architectural rule book that powers every device you own. So today, we're going to take a tour inside that machine. So let's just start with that big question right there. When you click an icon, how does a box full of circuits and wires actually think and give you a result? Well, it all comes down to something called computer architecture. And today, we're going to break it all down together. Probably the best way to wrap your head around how a computer is built is to think about building a house. I mean, you wouldn't just start laying bricks without a plan, would you? Of course not. You need a blueprint first, then you get the bricks. Computer design, it works the exact same way. And this right here, this is the key distinction. Computer architecture, that's the what. It's the blueprint. It defines all the things a computer is capable of doing, like its instruction set, which is basically just a list of commands it can understand. Then you have computer organization. That's the how. These are the actual bricks, the physical wiring, the circuit design that makes that blueprint a reality.
All right, so if the architecture is our blueprint, then what are the main rooms in our computer house? It's pretty cool, actually. Every single computer, it doesn't matter how big or small, has the same core set of rooms that all have to work together to get anything done.
So here it is, the basic floor plan. You can see there are three main areas that are always talking to each other. You've got the central processing unit, the CPU, that's the brain. You've got the main memory system, that's its short-term memory, and then the input-output system, which is how it communicates with us. Pretty much everything a computer does involves these three sections.
And when you boil it all down, a computer really only does these three things. It takes information in, it crunches that information based on a set of instructions it has stored away, and then it spits the result back out. Simple, right? But, the magic is all in how it does that processing part.
So let's talk about that input/output system, or I/O. Just think of it as the way the computer talks to the outside world. Input is you talking to it, say with a keyboard or a mouse. You're knocking on the front door. Output is the computer talking back to you through the monitor or a printer. That's the letter in the mailbox.
Okay, now let's head into the most important room of the entire house, the control center. This is the brain of the whole operation. This is where all the heavy lifting happens, the central processing unit. The CPU really is the engine. It's where all the instructions are actually carried out and where data gets processed. Without it, a computer is just, well, a collection of useless parts. The CPU is what turns that box of electronics into an incredibly powerful calculating machine. Now, inside this engine room, we find a few key specialists. There's the arithmetic and logic unit, the control unit, and then some really tiny, super fast memory called registers and cache. They're for holding on to data that's needed like right this second. And listen, each one has a super specific, super important job. First up, the ALU. Let's call this the workshop. This is where the actual work gets done. So if you need to add two numbers or compare if one value is bigger than another, the ALU is the part that handles all of those math and logic operations. Now, that workshop can't just do things whenever it feels like it, right? It needs a manager. And that's the control unit. It's like the site foreman. It reads the blueprint, the instructions, and tells every other part of the computer what to do and exactly when to do it. It's the conductor of the entire orchestra. So, our foreman has the instructions, and the workshop is ready to go. But where are those instructions and all the data they need to work on actually stored? For that, we need to visit the computer's library, its memory system. And this is such a crucial point. Every app you use, every piece of software, it's just a program. And a program is just a long, long list of instructions. That whole program has to be stored in the computer's memory, so the CPU can get to it, read it, and execute it. But here's the thing, not all memory is created equal. There's this whole hierarchy, and it's all about trade-offs. Think of cache as the sticky notes on your desk. Super fast to grab, but you don't have a lot of space. Main memory, or RAM, that's like your office filing cabinet. It's bigger, but it takes a little longer to find stuff. And then secondary storage, like your hard drive. That's the giant archive warehouse downtown. It holds everything, but it's the slowest to get to. It's this constant balancing act between speed, size, and of course, cost.
Okay, so we've toured all the main rooms. We have our foreman, we have our workshop, and we have our library. Now for the really fun part. Let's put it all together and actually watch how a single, simple command flows through this whole system.
We're going to follow one of the most basic things a computer can do. Add two numbers together. Let's say 5 plus 7. Here's how it all goes down, step by step.
All right, step 1. You type 5 plus 7 on your keyboard. That keyboard is our input device. It sends the numbers, that's our data, and the add command, that's our instruction, into the computer.
The computer gets that info and immediately places it into main memory, our filing cabinet. Both the instruction and the data get a specific address, kind of like a file number, so the system knows exactly where to find it later. And now our foreman gets to work. The control unit looks at its to-do list, sees the add instruction is up next, and goes and grabs it from that specific address in memory. It now knows exactly what needs to be done.
The control unit then sends that instruction and the data, our numbers 5 and 7, over to the ALU, our workshop. The ALU does its thing, performs the addition, calculates the result, 12, and just holds on to it for a second. And finally, our foreman, the control unit, takes that result, the number 12, and sends it to an output device, your monitor. And boom, just like that, the number 12 pops up on your screen. And here's the incredible part. This entire process, this whole song and dance, happens in a tiny, tiny fraction of a second. And that's really the magic of it all. From this incredibly simple blueprint of input, process, and output, we've built everything from basic calculators to entire virtual worlds. The fundamental architecture, that blueprint, has stayed remarkably consistent. The only limit, really, is our imagination. So the real question is, what are we going to build with the next blueprint?